Hi, welcome to Unit 5, Day 6. This is Part 2, where we'll discuss decomposition reactions. So in Part 1, we looked at synthesis reaction, which are the reactions where you combine reactants to form a single type of product. Now we're going to look at decomposition, which is sort of the opposite. We're breaking things down. So decomposition reactions. Remember, decomposition means to break down. And in a decomposition reaction, one type of reactant breaks down into two or more types of products. So you can recognize it as you see in these examples. You will start with one thing and it breaks apart into two or more things. And a good way, if we're just taking a closer look at example A, we have our one reactant, NH3, and it breaks apart into N2 and H2. So remember, the reactant is what we start off with and the product is what we make. Okay, so now that we've done that, we have a set of four example reaction equations here. Which of the following is not a decomposition reaction? So it's not a decomposition reaction. Pause the video now. When you press play again, the answer will be revealed. The answer to that will be choice D. So choice A, B, and C are all decomposition reactions because they all have one reactant. They start off with one thing that breaks down into two or more products. In these cases, just two products. Choice D, on the other hand, has two reactants, and a decomposition reaction cannot have two reactants. All right. Next CFU. So again, we're practicing balancing equations here. We're going to balance a non-decomposition reaction, and you want to do this on a separate piece of paper. So I sort of helped you to just remind you what the setup should look like. You're going to tally out or count the number of atoms on both sides of the arrow, and then you'll change the coefficients until you have the same number of atoms on both sides. So pause the video now, and when you press play again, the answer will be revealed. Great, so here is the answer. You should have a coefficient of 2 in front of aluminum, 6 in front of HCl, 2 in front of AlCl3, and 3 in front of H2. Just to sort of help you see that this is balanced because we have the same number of atoms on both sides, you can either look at the count that I have here or the particle diagram. So on both sides, you have 2 aluminums. You have 6 hydrogens, not 4, and you have a total of 6 chlorines as well. All right, I went ahead and made those corrections there. So there's 6 hydrogens and 6 chlorines on both sides. Now, if you need additional help with how to balance the equations, there will be a separate video for extra help in your Schoology folder, which will show you how I did this example. All right, next CFU, you're going to label each reaction as synthesis, decomposition, or neither, and then explain your choices. So pause the video now. Meant to mention that these equations are actually balanced. So if you remember in part 1, when they're balanced, you're going to ignore the coefficients. And what do I mean by that? If you look at example B, you just ignore the 2 in front of Na and you ignore the 2 in front of NaCl, and you would read this as 1, 2 reactants and then just one type of product because it's the types, not the numbers. So ignore the coefficients. Pause the video now, and when you press play again, the answer will be revealed. So the first one is a decomposition reaction. We're starting off with one type of reactant and producing, in this case, 3 products. So as long as you produce 2 or more products, different types of products, you are it's decomposition. For synthesis, this is the second one, synthesis, because we have 2 types of reactants, Na and Cl2, and it produces one type of product. Remember, we ignore that coefficient of 2 there. It's just one type of product here. Here we have neither. We start off with 2 reactants, 2 types of reactants, and 2 types of products, so that's neither. And then the last one is synthesis as well. In this case, we're starting with 1, 2, 3 types of reactants to produce one type of product. Once again, we're ignoring those coefficients. All right, so this was our success criteria for today, and so far we did the first 3 things on this list. The last thing is expressing a chemical reaction equation in words, and this really helps our scientific communication. And specifically, it's important to sort of practice this is because by being able to express a chemical reaction equation in words, it strengthens our ability to recognize each type of reaction because we have a better understanding of what's happening during each reaction. So we'll just do a couple of practice problems, but first I want to show you what that looks like. And we'll start off with a synthesis reaction. All right, so here's an example of a synthesis reaction. It's balanced. And when we're expressing this balanced equation in words, what we're going to do is we start off with the reactants. We'll say whatever the reactants are, combine to form, or we can say produce, and then whatever the product is. So in this example, we would say CO and O2 combine to form CO2. All right, so CO and O2 combine to form CO2. Or we can say instead CO and O2 combine to produce CO2. Same sort of thing. You can also, you also notice here that we're ignoring the coefficients. You can include that. You can say 2 COs and 1 O2 combine to form 2 CO2s, but just for simplicity's sake, we're going to ignore the coefficients. And final little note here, instead of the word form or produce, we can also use the word make to express what's being made here in our product. All right, you want to try this CFU. You're going to express this synthesis reaction equation in words. So once again, pause the video. When you press play again, the answer will be revealed. All right, so using the sentence frame, you should have something that sounds like this. Fe and S8 combine to form FeS, or Fe and S8 combine to produce FeS, or combine to make FeS. All right, so that is for a synthesis reaction. Let's take a look at a decomposition reaction. Decomposition does something different. Instead of combining things, reactants break down. So how would we express that? Well, in this case, we would say the reactant, whatever it is, decomposes or breaks down to form whatever the products are. So for this example, we would say NH3 decomposes to form N2 and H2. Or we could say NH3 breaks down to form N2 and H2. So again, you can use different words. Also for the word, instead of using form, we can say makes or produces those things. So that part is up to you. All right, but the main thing is instead of saying combine for decomposition, you're going to say decomposes or breaks down. Okay, so here is CFU 8. You're going to express this decomposition reaction in words. Pause the video now. When you press play again, the answer will be revealed. Great, so it may sound something like this. NO2 decomposes to form NO and O2, or NO2 decomposes to produce or makes NO and O2. All right, and one last note here is noticing that synthesis and decomposition, they're sort of opposite processes. You can think of them as opposite processes. Whereas in synthesis, reactants are combined. In decomposition, those reactants break down. So if we look at the synthesis and decomposition example C, we can clearly see that they're opposites. Notice how in the synthesis reaction, we're starting off with H2 and O2. Those are our reactants to make H2O. The flip happens in the decomposition. We start with H2O to make H2 and O2. So sort of the reactants and products reverse in a synthesis versus a decomposition reaction. So let's try one final CFU. Above you have the decomposition of NH3. And what I want you to know, be able to do is based on the decomposition that's shown above, which of the following reaction equation best represents the synthesis of NH3? All right, so remember they're opposite reactions, so you're looking for the opposite. Pause the video now. When you press play again, the answer will be revealed. The answer is choice C because all we did was essentially just flip the reactants and products. So we made N2 and 3H2 as our reactants here, and then we made the 2NH3 as our product. All right, that is it for this video. You have some demos to watch and an exit ticket to take. And that's it. Have a quality day.